My name is Sathish KS. I head the engineering in Zeotap. I have 18 years of IT experience, and the past 8 years I have spent in developing big data pipelines across various domains, the current one being AdTech and MarTech, and previously on e-com companies, and prior to that in IoT space as well. And today I'm going to present on the data governance and the multi-tenancy and how the mix-up of both has an interplay on what we are building as an engineering organization. Thank you and hope you will enjoy the talk. Data governance is a hot field into which multiple companies are investing into. And with the advances in cloud tech on big data, multi-tenancy is also on the rise. This combination throws challenges which touches the whole org, including the business teams, technical teams, legal teams, and the product teams, and obviously it has implications on people, product, and tech as well. Now, there is a question on where do you commit your engineering to for achieving governance goals in terms of building a product or tech? And this talk is an attempt to show areas where tech heavily contributes to. I'm not going to concentrate on the people or process or the procedural aspects here. It is mostly towards the product and tech alignment in this particular talk. A quick intro about my company, Zeotap. We are a customer intelligence platform on a mission to help brands to better understand their customers. Having said that, we have a SaaS offering, a pure DAAS offering, as well as a combined offering as well, which is integrating to the AdTech and the MarTech ecosystem. We have a very large data asset, which is people-centric. When I say large, it is in 24 billion odd count, which we have across 500, 600 dimensions. And given the sensitivity of this data which we are handling, we have invested time in building a privacy compliant system. And we are one of the earliest companies to be GDPR compliant as well. Now, coming to data governance, one of the foundational papers on data governance has been by Guthrie and Brown way back in 2010. And if you survey recent literatures as well, they build on these core concepts of data principles, which talk about data as a key or a valuable asset for business and the need of proper data quality measures to understand their usage in business. And also the metadata capturing aspects and the access controls which are needed, and also the life cycle management of the data. Expanding on this definition, if you look at the current definitions from the Data Governance Institute or the Data Management Institute, DAMA as it is called, a couple of jargons you come across. One is cross-functional, since it affects all the org, and it is also a framework which gives structure to data management, which results in well-defined policies. Another benefit being compliance adherence, enforcement of monitoring and auditing, and it extends to not just facts and representation of the facts, which is the data, but also on the value and the information as well. Now, the most important takeaway of this slide, or one of the key takeaways here, is you need to understand that you cannot govern what you don't know. Okay, so we are going to build upon this concept in the following slides as well. So just remember this, you cannot govern what you don't know. Now, suppose you as an organization are embarking on a journey to start governance product or a governance-based product. What are the broad goals you would be looking at? Is to democratize the data with adequate security in place, also have good compliance adherence, and also have a good measure of the quality of the data as well. And that is what I have listed in the left-hand side of the slide in terms of the product modules which you would be building. One is for the exploration of the data and assignment of ownership and knowledge contribution or the lineage angle, the access rights, how do you give it, categorization and the usage and the use case of the data, and apply rules to adhere to certain compliance, then the metering, the outflow, and the usage of the data, as well as the derivation and the inference history, because currently data comes from various generations, being A being another medium which is generating the data as well. Going forward, what are the challenges which you might encounter, or which you will definitely encounter when you are building a data governance product? Is that one is the changing regulations. Regulations keep changing and new regulations come into play. And other thing is you are getting more variety of data. Just as I quoted, there are now AI-generated data which is coming into play, and there is PIA initially was just the email and the name and these kind of things, but now you have biometric PIA as well. So the variety of data is increasing day by day. Then the country-specific regulations also come into play. Also, another thing is the data ownership. There is a constant flux, and you need to keep up with the flux of the data ownership. Building on these features, I just listed out what could be the building blocks, what you might have within your tech product for a governance item. Key being the inventory, the asset inventory of the data, which is a classified asset in your ecosystem. And under each data asset, you will have the data level inventory in terms of schema data types. We just talk about that. Then the lineage or the knowledge source, and also what is the security mechanisms that need to be applied. And adding to those blocks are, of course, the quality, which is another pillar. And quality can be on multiple dimensions, from plain statistics to the freshness, recency, the sparsity of data, and what are the anomalies which you get. Have you deduped your data? These kind of qualities which you quality metrics which you measure. Then, of course, you need policies to govern and take actions. And when you take actions as well as processing policies, you need to alert as well as hook them to the monitoring for audit logging and analytics purpose in terms of, for a governance perspective. Now, already in governance, we have a bunch of items which we need to take care of. Now, if you throw in the multi-tenancy angle, what happens? So when you hear multi-tenancy, what comes to your mind? Self-serve. Second thing is minimal operational support. Third thing might be the same code is running, of course, with some customization of the application. But here it is not application, it is the actual data itself. With all these, the context under which the system operates changes, or to put in right words, it actually expands. The context has an explosion in terms of a multi-tenant data governance. Now, when I say context, just to list down the important context which work on the governance angle. One is the organizational context. Organizational context creeps in a way, say, an organization collects only personal data, and another organization is giving product data for all processing rights. The requirements of each of these organizations across the data domains, which we just saw as the building blocks, right? The profile, the quality, security, life cycle, everything changes. The second angle which comes in is the vertical angle. Vertical means, say, you take AdTech as a vertical and FinTech as a vertical. The compliance requirements for a FinTech are much more stringent than an AdTech vertical. And a compliance requirement for a personal data is much more stringent than a non-personal data. So these dimensions creep into the governance aspects as well. Then the other items which expand the context, as we told, is the application or usage. Say, for example, FinTech might use the data for analytics purpose to give the right coupons to the end customer, whereas AdTech could be using it for a personalization use case or a marketing with the right data set use case or a targeting use case. So this throws in additional complexity. The other angle is the multi-tenant architectural implications itself. In the sense, multi-tenant data lakes can have three kinds of architecture broadly, if you want to classify. One is a shared everything architecture. In the sense, you namespace it and share everything, including the processing assets and the storage assets. Another is a shared nothing. This might be a specific client requirements which says absolute no to mix my data with anything else. I need very complete perimeterized security around what I'm doing. So that is a shared nothing architecture. And there could be a middle ground where the stateless applications are shared, and the stateful means the data which is processed and stored, it is not shared. So this also throws in aspects into the governance as well. Moving forward, what happens is, fundamentally, with all these complexities in place, data governance is also becoming a big data problem in its own. And we need to solve it applying how you will apply data engineering principles towards big data itself. So that is the essence of where we are coming into. Now, let's look at building the bits in the sense, when the question comes, what as an engineering org I am going to invest in if I am going to start a governance program in a multi-tenant data lake? First thing, let's remember what we talked about a couple of slides back. Is the principle is you cannot govern what you don't know. So, first and foremost, you need to inventorize or you create an asset inventory so that you know what all is available with you and also have a continuous capturing mechanism of what is available with you. By the way, since we have already thrown in the concept of multi-tenancy, going forward, whatever I am going to talk about, ask a question. If this has to be self-serve and zero ops, what is needed? That is the multi-tenancy tangent. Have that as well when you are going through each of these slides. Now, coming back to this slide, you could see this as a maturity model of sorts, where the dimensions about what you know increases with each level. So let's quickly climb on each of the level and figure out what additional things we are knowing at each level. So first thing is just the data. It's like a MySQL table is there. You have a schema. You understand what are the data types, what are the value range, what is the cardinality, etc. Second thing is you get the lineage, where this source has come from, who has contributed to it. And the third thing is whether the data set you're talking about, is it a raw data asset or inferred, or you derived it via some algorithms. Then the fourth thing is where all it is stored. Now that is a location angle, and along with it couples the versioning of the data. Now there is a small twist to this in the sense location can be multiple for a single data asset. So logically it is the same data asset, but if you apply the classical warehouse concepts of hot, cold, and warm data storage, the physical asset is going to be different, whereas the logical asset is going to be same, which is where versioning also plays a real important role because you are going to sync between these assets as well. And what is the purpose it is used for? That is the usage angle. And who owns it? Now, ownership is different from access. So ownership is the person who's accountable for the data and he authorizes access to other person for usages. He can look at, okay, this request has come to me and saying I need to use this data for so and so reasons for so and so many days. And he says, okay, I can give you this role for you. All right. So that is another angle. That is the ownership angle. And who uses it? Who uses it? The roles can be again customized and it depends on the bunch of contexts which I listed before in terms of the organizational, vertical, and all those contexts. The roles might also be different. There might be a hierarchical nature. There might be a temporary role which is acting only for 2 days, 3 days, then it goes away. So all those nuances come into play. So role with a TTL is possible, is what I'm trying to say. Then the final thing is if you can apply all this with the rules itself, in the sense you have governed policies on all these effects, in the sense if it is this schema and if it is a raw data set and if this is the role, you have to give him access only for 2 days. That is a rule which you can take as an example if you're applying governance at the catalog level itself. Okay. So that is kind of, I would say, maturity in terms of what all your catalog is going to hold and how you're going to build it and how your processing pipelines, everything is going to feed into it. Next item we need to be aware of and manage are the policies. Now, policies, in the sense, I told about the self-serve UI angle, right? So you need to have self-serve rule creations for multiple purposes. And this has to be parameterized in a way. So that is why we are having policies and actions. Let's look at a policy which will act at a record level. So I have listed a couple of policy types, examples, which can act on schema level, the value level, or the record level. Let's take one example which acts on the record level. Let's say consent. You are managing consent policies. So there are two angles to it. One is the ingestion. User is giving a consent on the browser and that is coming into your system. Now that consent you need to harmonize with the framework which the org is adhering to. It could be a TCF framework under GDPR or a CCPA framework. So you are mapping the user to the framework level consent, which is kind of a user to the purpose what he has accepted for mapping. The second angle of the consent is going to be rules which govern. Suppose say my usage is running a personalization algorithm. I need to look at the user consent A and B. Suppose I need to run a marketing algorithm. I need to have consent B and C. So this set of rules, that is on the usage end of things. So these are the kind of policies which will act on the record level, which would be stitched on the runtime pipelines. And the second thing is the action. Every policy, you will have some actions for a couple of policies. And a classic example is, say, you are getting sensitive data and you have a sensitive data blacklist, and you are saying, the policy says that if a schema has a column which is part of a sensitive data blacklist, drop it. Now the drop becomes a drop action, and drop action actually nukes the column for you, or it can nuke the cell for you. A null action is it nullifies the value instead of nuking the actual column itself. So those are a couple of examples on the policy and action. And just look at the last line here. So how it works is, the rules are sometimes augmented with thresholds and runtime parameters, and the action to be actuated is a function of the policy and the parameters which are stitched together in runtime. Okay, so just remember this equation. We'll allude to this later, because this why this is important is we'll know a little down the line of how to apply it in a auto governance style of program. Now, another dimension which changes is the life cycle of the data itself. Traditional data sets might follow the CRUDA, means the create, save, update, delete, and the archival life cycle. But if you look at a data lake or a multi-tenant data lake, you have a bunch of sources from which you collect the data. Then you have the processing, you have an analysis which creates a value out of the data. Then you can share the data and you EOL the data. Now, the source who actually gave the data, he's the owner of the data, and he has the rights to say, go and terminate my data. So that is a EOLing of the data. Whereas if you look at a sharing kind of scenario, you have a consumer and you have a sharer. You might be the sharer, and you might have a consumer as well. So this is how the ownership and the roles change with respect to the life cycle of the data itself. So ownership, as we spoke in one of the previous slides, he is responsible for assigning additional permissions as well, and he's accountable for the data set at each of the stage, or the output of each of the stage, in terms of everything, the quality metrics, whether it has gone to the catalog, whether the right access rights have been pushed, and all these things, right? So that is the other angle in terms of the life cycle and the ownership. Then another major pillar, right from Khatri's paper, and if you look at the last 10 years literature on data governance, is how quality has an immense effect on the value creation of the data itself. Low quality data can really disrupt your business, whereas a high quality data can be a real revenue generator. So the quality is linked to the usage. And in a way, the quality metrics which you provide, you could say, let's business check whether it is whether the data can be used in a particular context, or say whether it is feasible to be used in a particular context. So that is how important a quality metric is. And the typical pattern of a quality metric is you monitor, you detect any quality changes, and you propagate it or alert the relevant stakeholders around it. Right? I just wanted to mention a couple of tools which have been maturing in the past 2 to 3 years in terms of data quality metrics. One is AWS DQ. This is giving a first-class citizenship to quality. It is a library. If I remember correctly, it has some 35 to 40 odd out-of-the-box statistical metrics, and you can also add more things to the library and stitch it with your processing pipelines. Second tool worth mentioning is Griffin, which is a platform style more than a library style. Then one old tool, which it's a little old tool, but from the profiling concept angle, it's a very good tool to know about. It's called the datacleaner.org, again, a free tool to use. And one surprising tool is Great Expectations. They are in experimental mode to achieve auto profiling. Definitely take a look at that. And it is a very good unit testing tool as well in terms of your data pipelines. Now, there is one problem. We were talking about Lineage in one of the staircase of the catalog, right? Now, Lineage has one unique problem when you are running a DAAS multi-tenant. When you have, say, 100 data sources, you are blending the data together. A couple of challenges which may come into play is this: 2 data sources can give you the same value. In that case, whom do you attribute it, or what do you call the lineage of that data is? Second thing is, Data partner, one data source can say, this is of age group 50 to 55. Another data source can say, this is of age group 40 to 45. Now, what is the truth there? How do you assign the truth, and how do you assign from whom you got the truth? So this is if you think about it, this is a ML problem, or you can solve it in a heuristic manner as well. And all your quality metrics can be a feature into this, which feeds into this. And that could be also business levers, which helps you. And you need to invest on the right kind of attribution stamping for Lineage, because that will help you in terms of creating the right value from the data. So this is a very unique problem which you'll run into when you're doing a DAAS multi-tenancy as well. When you're blending data, of course, with a shared everything architecture. If you think about it, this is similar to the lifetime value calculation problem of multiple customers. How do you calculate the lifetime value? Here, instead of customer, it is the data source. You're trying to achieve a value calculation of each of the data source and apply the weights accordingly to the attributes. Now, if you think about it, all the previous items in terms of giving holistic governance actually interplay together. You have a data set from org1 governed by, say, compliance framework CCPA, which has owner X who has given permission to Y for marketing purpose. I have to profess my love for all things graph here, and this multi-relational transitively linked problem domain is best represented by a graph structure. And a couple of additional things which you need to have support on your catalog is on the search lookups, as well as runtime updates when you are having a registration system or onboarding system, when the processing is outputting to it, as well as AML generated outputs are going into that system as well. Right. So these are a couple of things. And no wonder many of the popular tools which are in the market now are just vindicating my stance on using a GraphDB as a backend storage for this problem. The tooling is actually maturing in rapid pace. You have cloud-native tools like AWS Glue and Google Data Catalog as well, which came out of beta recently. And the poster child, of course, is the Amundsen. It's a wonderful tool. Take a look at it. It's open source from Lyft. And Apache Atlas, the beauty of Apache Atlas, it has an extensible entity and type-based system, wherein whatever dimensions which we talked about in the past slides, you can actually model it and extend this system. And it is backed by genus graph abstraction over a white column store of your choice, and it uses Elastic for indexing as well. And off late, one of the very wonderful project which I was really impressed with is what these Atlan guys are up to. Definitely check this out. In terms of clarity of what a governance tool should have, they have put immense thought to build that particular product. And on similar lines, another product is the Marquee project, which is, I forgot from which company. That is also a very nice tool. So conceptually, you can look at all these tools as well to help in your governance models. I just listed out a bunch of items based on the previous slides if you're going for a tool evaluation. One important thing which I would like to highlight in this bunch of items is the last item. Imagine you have created this whole graph, right? It's a bunch of data and it has a bunch of features as well, right? And this, if you feed to an AI-based system and it sends in recommendations, that actually becomes like an auto governance setup. So the bulk export capabilities of this tool becomes good to have if anybody has a bandwidth to look at a AI-based governance, which will be feeding from this graph and again feeding back into it as well. Right. So that is one thing I just wanted to highlight in this slide. Other things are pretty much self-explanatory. You can just check it. Now, we just talked about the policies, which were more towards the processing or the runtime aspects of it in terms of the security policies, which you can apply in terms of the policies which you can apply there. And this particular slide is more towards the infra end of things. What are the security policies which you might need to provision in terms of a multi-tenant data lake? And of course, the principle you want to go ahead with when you're creating a infra level security is the zero trust and the positive security model. For perimeter security, if a client asks for perimeter security, of course, you have the VPN on cloud and Apache Knox, which is again open source, which works both in Google Cloud as well as AWS. Sorry, my knowledge of Azure is a bit weak, but with GCP and AWS, this is a tool which works out of the box. Then you might need an attribute-based access control mechanism, your own RBAC and access mechanisms. A couple of other requirements, of course, masking of sensitive data, encryption, hashing, data in motion, data at rest, encryption, hashing. If you go to GCP, you get it out of the box. So it takes a lot of headache from your head in terms of data at rest encryption. And the last thing which I want to mention in terms of infra management of security is in a DAAS business, typically you might be exchanging data with an external partner. In which case, the lifecycle management of that data set and that key is very important. In terms of, say, when your new consumer is onboarding, you need to create new key sets for him. And if a consumer is offboarding, you need to delete it adequately. Just like how a user comes to your company and leaves the company. So similar things, similar rules apply here as well in terms of security, infra security. The next thing is audit and monitoring. We'll just talk about audit because monitoring is more of a hooks into all the processing systems that you have. In terms of audit, there is one, I would say it's not a mistake, one architecture people follow in terms of pushing all the logs to Elasticsearch and indexing it. But for audit, at least try not doing it because this doesn't have a TTL. You might need to retain 10 years of logs or 5 years log. You never know when the compliance is going to hit you. So properly defining a grammar and making it queryable via SQL on Hadoop, partitioned data set creation would be very good. If you are looking at our service, create a common compliance logging mechanism with a proper definition of the grammar. And a couple of things I have listed there in terms of the grammar of what to be there, in terms of the enforcement, what has happened, what is the violation type, which product did it, what was the data flow stage, and the action taken. In a way, you should be able to relate it with the items which you're storing within the catalog in terms of the knowledge, right? So that is important in terms of the important pointer for the audit service. Now, we have talked about so many things. To actuate all this, you need to definitely invest on automation of your data pipelines, or what in current parlance is called as declarative data pipelines or declarative workflows or workflow as a code. Okay, so that really helps in stitching together all the runtime pieces so that they operate within the governance mechanism. And if you are having declarative pipelines, you definitely would be, I would say, evolving to have a functional repository, say a bunch of enrichers. I'll just show you a bunch of functions which is good to have for the rules processing as well. So you might invest in a functional repository as well, and more like a runtime reflection. Old days we used to do the Java libraries reflection. So similar way you might use the functional repository to send in the parameters which comes in the data and actuate things. So a couple of tools for declarative pipelines. Of course, the poster child, as everyone loves, is Airflow with its bunch of operators. And upcoming tools, there is something called Prefect. Definitely take a look at it. Airflow doesn't give, say, first-class citizenship to parameterized dynamic workflows. You can achieve it, but you need to do some little hard work around it. And the scheduling support is not out of the box for, say, irregular schedule or some workflows which doesn't have any schedule at all. So these are all solved in the Prefect approach. And again, it is open source. You can look at the concepts and principles there. And another thing, it's interesting I mentioned it here because this is a single person repository. But I thought from a declarative data pipeline perspective, their emphasis on output versioning and the success detection. Success detection is a very big problem in say, any data pipeline input output. So that is something which you can look into. That's called ALA mode. I've just given the link there. So these are all a couple of things which helps in dynamic data pipelines. Of course, you have some cloud native tools as well, like Google Cloud Data Fusion, which gives API based. You can pass in JSON for all the pipeline stages, and you can add the custom enrichers whatever you want, and it can ephemerally create a data proc cluster and do the processing for you. So cloud native tools are also available, but I'm just listing out all the popular open source items here. Just a laundry list of the functions which you might have in your function repository. Pretty much everything is self-explanatory. I thought I'll just list it here for the interest of the talk which we are giving. Next thing is, I thought I'll put some generic reference architecture. Then I decided, let me put what we are doing in Zeotap itself. Of course, let me put a disclaimer here. We haven't reached 100% automation in all the items, but this is a journey we embarked in 2018, and we are building towards achieving, say, no #no data engineer, complete self-serve kind of model, and minimal operational support kind of model. But I thought, in terms of architecture, it might be worthwhile to just take a look at what we are up to. So first thing is, in terms of offering, our SaaS business is a complete shared nothing offering, and a DAAS is a shared everything. And we have one product around ID resolution, which has the shared control plane, but it has behind the scenes, it shares the database based on namespace-based provisioning system. We have invested in something called a provisioning manager or a provisioning system, which all the assets which I talked about, right? The infra assets as well as the user and the access and all these things, say something like a data proc, a BigQuery, or a GCS buckets. All these are actuated by the provisioning system. And there is a control plane for the state monitoring, and so fundamentally a life cycle management of all these systems. And we have borrowed these concepts heavily from the SDN, or the software defined network architecture, which came in way back in 2006, 2007. So it follows principles from there. And one thing we consciously avoided is we avoided writing many scripts for our IaaC, rather go with the API mode. One thing is it is very unit testable, and adheres well with CI/CD semantics as well. And with the testable IaaC, what we offer in terms of guarantees is the SLAs are managed. So in cloud, not all assets are created at the same speed. There will be some assets which take a long time to create, and some assets which get created very quickly. And second thing is error handling and retry mechanisms. That means you get transactional guarantees. Whether if it is a yes, the asset has been created, that means it is definitely there and ready to be used. If it is a no, means you need to go and look at a retry or reissue the command. And another additional thing which you get of this system is we have a complete labeling mechanism which helps in the ease of billing. When you're doing attribution of the cloud bills, when it comes to you have a ease of billing as well. Now, coming to the provisioning system, as I told, it supports all these three architectures, and it heavily uses the cloud APIs and some custom APIs. And we have in-house developed a tool on which one of my colleagues is giving a talk as well on one aspect of the tool. So the control plane, we named it as Mr. Shepherd and Kingpin. These are based out of Apache Camel, though little old school in terms of software. Apache Camel, it does its job wonderfully well. And it provides abstraction over Airflow, Uzi, and Livy. You can use all these systems behind the scene. Then in terms of the compliance and consents, what we support GDPR, CCPA, and we are confident of supporting PDP, a bill which is coming in India as well, and frameworks out of the box. We give TCF and TCF 2.0. And also the beauty is we have a self-serve rule engine where you can compose your own rules, which will be converted to DSL behind the scenes and applied during processing as well. Architecturally, how it looks is, just let me split it into a top-down and bottom-up. So the top is what the admin is going to do when the org is getting onboarded, what he's doing. So for all the org, what he's creating is either a per tenant processing and storage or the namespace tenant processing and storage, depending on the product set the org is going to access. And the provisioning system is going to has a bunch of services in terms of infra services, taking care of all the infra assets like cloud data flow, PubSub, yeah, BQ buckets and all these things. And the API is supportable to AWS. In fact, we were in AWS before, then we moved to GCP. Then user services takes care of the complete user management, access, ownership, as well as the roles around the users, hierarchical user management, hierarchical roles, everything is available. Consent services, as I told, there is a org level consent in terms of what are the usages he needs to register for and what is the framework he is adhering to. It could be region-wise framework. In US, he can say I'm adhering to CCPA. In EU, it's GDPR. Then the security services, then the catalog itself. And the bottom is once all the top layer is provisioned, the bottom guy, the actual user guy comes in. He's the guy who's actually working with the data. He comes and creates the data sources and how the enrichment has to happen, how the UTL has to happen, and what are the additional things, and if there's to be a export and the egress time rules, what is to be applied, and all these kind of things. So internally, we call it as a data processing management console. But here, for want of a better word, I just put it as an orchestration system, which provides a workflow service. Of course, the function repo we talked about, internal state monitoring, job state monitoring, everything. And the DSL services for the custom rules, which is being created on runtime. So this is the final architecture slide, just to showcase how our systems are differentiated. For our first party, completely it is a per tenant based system, which is being provisioned by the provision manager. These are all internal processing layers, which is there. Then for the third party, it is a multi-tenant in the sense it's a shared all architecture, which is where I talked about lineage and attribution and all these items, which is coming to there. Everything goes to the storage. You have different storages here. And this is the cross-tenant, the applications, which work on data from both ends. The beauty here is any raw data from here can flow into the system, but there is no raw data which is flowing out of this system. In the sense, this raw can be mixed with this, but this cannot be mixed with this. So from here, what you're getting is only the cohorts and aggregates which can be used for various use cases. So we have a bunch of apps. I just showcased a couple of apps to show what is happening here. So that is the end of what I had to talk about. Thank you. And also, I want to thank Qball for arranging this wonderful Data Lakes Summit. And also thank you for giving me an opportunity to present in this summit as well.